Have you ever gazed at a rainbow and wondered why it's round when viewed from above? It's a common curiosity, isn't it? We've all noticed that rainbows aren't just simple arcs in the sky, but rather, they form a complete circle when observed from a high vantage point. Now that's quite intriguing. This round shape isn't just a random occurrence or a trick of the eye, it's a fascinating result of the way light interacts with water droplets in the atmosphere. Yes, those stunning bands of color are the product of a dance between sunlight and rain. So, why are rainbows round? Why not square or triangle or any other shape for that matter? Is there a special reason behind this circular form? Or is it just a coincidence? You might be surprised to learn that there's a lot more to it than meets the eye. Well, the answer to that lies in the beautiful science of light refraction. So, let's dive in, shall we? To understand rainbows, first we must discuss light. Now when we think of light, we might imagine a bright white beam, but in reality what we perceive as white light is a beautiful cocktail of different colors. Each of these colors has its own unique wavelength, from red with the longest wavelength to violet with the shortest. It's like a symphony, where each instrument plays its own note, but together they create a harmonious melody. In the case of light, this melody is white light, and the instruments are the different colors, each playing their own wavelength note. Now here's where our raindrop comes into play. When this symphony of light encounters a raindrop, something fascinating occurs. The light refracts, or bends, as it passes from one medium, the air, into another, the raindrop. Why does it bend, you ask? Well, think of it like this. You're running a race on a solid ground and suddenly you have to cross a river. You'd slow down, right? Similarly, light slows down when it moves from air into a denser medium like water, causing it to change direction. This change in speed and direction is what we call refraction, but here's the catch. Remember how we said each color in the white light has its own wavelength? Well, each of these colors bends at a slightly different angle when it enters the raindrop. Red light bends a little, and violet light bends a lot. This is because each color travels at a slightly different speed in the raindrop, so when a beam of white light enters a raindrop, it splits into its component colors. This is known as dispersion. And it's this bending of light, this refraction and dispersion, that plays a crucial role in the creation of a rainbow. So next time you see a rainbow, remember, it's not just a pretty arc of colors in the sky, it's a symphony of light, playing out its melody through the medium of raindrops. Now imagine a shower of rain mixed with sunshine. That's a perfect recipe for a rainbow. To understand how a rainbow forms, let's visualize a single raindrop as a stage where the magic of light unfolds. When sunlight, which is white light, encounters a raindrop, it doesn't just pass through. Instead, it bends or refracts. This happens because light travels at different speeds in different mediums. In this case, it slows down when it enters the raindrop from air, causing it to bend. But the story doesn't end here. Inside the raindrop, the refracted light hits the inner surface. Some of it escapes out, but a significant amount reflects off the inner boundary. This is an internal reflection, and it's crucial for the formation of a rainbow. Now the reflected light heads towards the other side of the raindrop. Once it reaches the boundary between water and air, it refracts or bends again as it speeds up while exiting the raindrop. This second refraction causes the light to spread out even more, creating a fan of colors. Here's where it gets even more fascinating. The white sunlight we started with is actually a mix of different colors, each having a unique wavelength. When the light refracts, these colors separate because each color bends at a slightly different angle. This process, known as dispersion, gives us the spectrum of colors we see in a rainbow: red, orange, yellow, green, blue, indigo, and violet. Oh, and why are rainbows round? That's due to the symmetrical shape of the raindrops and the angles at which the light refracts and reflects within them. When we see a rainbow, we're seeing the collective effect of light refracting, reflecting, and dispersing in millions of raindrops at once. The result is a circular arc of colors in the sky, a round rainbow. And there you have it, the science behind the round, colorful spectacle we know as a rainbow. So, to summarize what we've learned today, rainbows are not just beautiful natural phenomena, but the result of a fascinating blend of physics and meteorology. They occur when sunlight is both refracted, or bent, and reflected within droplets of rain. This process separates the light into its individual colors, creating the spectrum we see in a rainbow. The round shape of rainbows, when viewed from above, is due to the way light refracts within the raindrops at a specific angle. This angle, known as the critical angle, is always the same, leading to the creation of a circular arc. In essence, each raindrop acts as a tiny individual prism, bending and reflecting light to produce a spectrum of colors. The combined effect of millions of these raindrops results in the breathtaking spectacle we know as a rainbow. Next time you see a rainbow, you'll know exactly why it's round and colorful. Keep wondering, keep learning, and stay curious.